Hi guys, welcome to the Tech Granth. Today we are going to solve the problem minimum window substring. Do like and share the video, subscribe to the channel to get further update. So we are going to solve this problem. It is of type hard. It says that given a string s and a string t, find the minimum window in s which contains all the character in t in complexity O of n. Okay. So we have this string and we have t as ABC. So we need to find the minimum substring length in S which contains all the character from t like A, B and C. So let us see the string. So if I start from left side, I say A, D, B, C. So this is one substring which contains all ABC. It is of length 6. If we go further, we see that there is one more substring like B, A and C which contains everything from T, and it is of smaller length as compared to the first one that we had, this one or any of these. So we need to find the smallest one, the smallest substring from S, and it should contain everything from ABC. I'll solve it in the similar way like how we did previous problems, where we broke down the problem into smaller questions, and we'll solve each of the question one by one, and we'll see if it solves the entire problem or not. So first thing that we see as part of the question and the pattern from the input that we have is we need to keep track of t. So we need a track of t, basically all element and its count. We need the, because this can be like A, B, C. So currently A, the count is 1, B count is 1, C count is 1. But if something like this comes up, then you have A as count 2 and B and C as count 1. So we need to keep track of count also. So this is first thing that we need to do. Second thing is we need substring. We need substring from S which contains all character from T. So this is the second requirement that we have as part of the problem. So there is no point having a substring like this which does not contain all the character from T. So we need a substring from S which contains all the character from T. And third thing can be, to find the substring, basically we need the starting point. So we need a start point, and this start point will be in S. So start point in S and minimum length. So for this particular answer, the start point will be this B and minimum length will be 4. So I can extract that substring from this S. So these few things that are there which we require. Anything else? No, I don't think so. I think if we answer all these three questions, we should be able to solve the problem. And yeah, maybe a 2a we can add here, like once we have the substring, so we need some comparison to match if substring has all char from T. So these two will go hand in hand. These two can go hand in hand basically. So let's try to solve this. I'll take an integer array for string, and it can contain any character in ASCII. I'll take another integer array for the pattern. I'll say t array, and this also will contain everything from ASCII world. Now to track everything of t and find its count, we'll do something like this. We'll go through the character of t, and I less than t dot len I plus plus, and what I'm going to do here is for my t array I'll say t dot char at I plus plus. So what this means is, like, when I declared my t array or s array initially of 256 length, so the array looked something like this: 4 dot 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 till 255. This was the array. This is the initial t array or even the s array, and the value of all these was 0 by default. Everything was 0. Now when I say t array and the position of t dot char at I plus plus, it means that t dot char at I when I is equals to 0 is a. So it means t array, in t array you go to the position of a, so it will basically go to the position of ASCII character of a, and it will increment the value to 1. So it means that in my t array I have one value for a. Similarly for even for b and c, so it will be like 66, 67, all these will be like 1 1, and rest all will be 0. So for this particular case, my t array will look something like this. It will have all these these ASCII places will have value 1, and rest all will have value 0. So if I had like one more a here or a extra b here, so this count would have become 2, or b count would have become 2, and so on. So this way I'm able to track all the element and I'm able to track its count. Next we need to find substring. So for that I need a start, basically to go through my S array, and to I'm going to use two pointer solution, so I need a left side, so you can say start or left or anything, and we need a start index. Basically this index will be initialized to -1 for now, and this index will be the start point in S, so from where I need to extract my substring, and I need a min length. So min length can initially be some big value, so integer dot max value, and I may need one more thing. I'll say count equal to 0. Basically this count is for when I start from A and move towards means scan through this string. So I need a mechanism to tell whether this substring that I have, it contains all the element of t or not. If this contains all the element, then only I will check whether it is the minimum or not. Otherwise I will not even check that. Like if I have these three characters, when I scan these three characters, it does not contain all the element from t, so it is not relevant to me unless I read here. So count will be basically to maintain the length of the substring, or to span the substring till we have all the elements of t in the substring that we are getting from start to end. And finally the end part, we will track it using the index variable I, and it will be s dot length plus. So basically for my two pointer solution, one pointer is this, the other pointer will be this, and I will say S array. Now for S array also I need to do similar thing like how we did for T array. I need to enable the S dot char at I, and then I need to see whether the substring, like I started from 0, so I would go to 1 2 3 4. So when I reached 4 till I reached here, whether all the elements of t are present in this string or not. So for that we are using count, so we need to increment count. Now when we will increment count, to increment count we need to make a check basically, and the check will be the element that we are at currently, so whether that element is present in the pattern or this T array or not. So I will say if T array of s dot char at I is greater than 0 means that element is present. Like if D is if I am at D and D is not present in ABC, so there is no point of incrementing the count. If I am at B, so B is present in this ABC, so we can increment the count because that length has increased. But from here till here, now the two elements have matched out of this three, so that count basically will serve me that purpose. And one more thing we need to keep in mind is like suppose if this had two A's or multiple A here, so even if I start from here and go till C, the length will be very big, and this substring will contain everything, and I don't need to include all these for my count purpose because I need only one A, and even if there are multiple A's, it does not bother me. So I will say if my S array in my S array is dot caret I will move till this is greater than, actually this is less than equal to T array of same as dot caret I. So if these two conditions are met, then in that particular case I will increase my count. Okay, so if these two conditions are met, I'll increment my counter and I'll then check if count is equal to t dot length. It means that my in my counter I have covered all the elements. I have covered all the elements that is present as part of t. If these two are matching, then we need to see if like in this particular case we had multiple A's, so this substring forms everything, this substring also gives me everything, so I need to move my start pointer in a way so that can I find a smaller substring basically as part of this. So we can make a check here, so we'll say while my S array, if this S array and S dot char at the start, if S dot char array at start, if this is basically greater than the P array or the T array which is here, the T array S dot char at I, if this count means in this particular case A was like 4A, A had count 4, so this count is greater than the count which we require, so even 1A will do for me. Or we can put one more case where we need to ignore all these characters which is not present in T array, so we'll say T array dot S dot char at I if this condition is equal to 0. So in these two cases I will simply say start plus plus. So I'll move my start character. If suppose this was D, so since D is not in this, so I can just move my start pointer here, and I will put one more check for this. If this case is present where we had like a here, so if I move my start pointer from here to here, I need to exclude this element from my S array. So if this is greater than if S array count is greater than the T array count, so in this case I need to decrement this count. So I'll decrement it, and yeah, once this while part is done, so I should be able to get my start index basically. So if I have my start index, then I can do a check for my min length. If min length is greater than my right boundary, which is I, minus start, which is my left boundary, plus 1, then I have a new min length, which is I minus start plus 1, and also I have a new start index. So this start index will be the starting point of the window. So these two things will be there, and once we have the min length and the start index, which we were here, we need a start point in S. So this start index is the start point in X. So we will be able to solve the problem. We just need to come out of our loop, our for loop, and here we need a check like if the start index never got initialized, means we never got into the loop, so the value will still be -1. So if the start index value is -1, basically we don't have anything to return. The substring does not exist. There are no pattern where whatever we have in T is present in S. Otherwise we will return s dot substring. S dot substring, we have the start index, then we have start index plus whatever the minimum length that we have got. So these many characters we need to extract. Okay, so let us go through the program. We just use the array. We got the T array count, which answers our first question. So we need a substring which contains all the character from T. So that is what we are doing here. And then we need a substring comparison to match. So the comparison is happening here, which is based on count and the start array that we have. And finally we have a start index and a min length. So that seems okay. Let's run the code. We'll run the code. So let's see. Yeah, so it is accepted. Let us submit the code. And it is success. So like we saw initially also, if we break down the problem to smaller problems and try to answer each of them, we reach at the conclusion. So the code looks pretty simple now. If you have any question, do put it in the comment section. I will try to answer all the questions that are there. Thank you for watching the video. See you in the next video. Bye.